Yeah, so I mean, I actually wondered if I could just start by asking a question, Mike, because it's something that I've wanted to ask you in all the discussions we've had. And um, when we're thinking about sort of what can be an agent, uh, obviously the examples that come from your field are things that we can see in the cells and smaller more basic processes. And when when we try and think of the analogs in sort of psychological processes, some of the time at least, we're talking about thoughts or symptoms or sort of disease states. And I'm sure we'll come on to what some of the how we can conceive of some of those. I think, I mean, you have um, this lovely idea of trying to see disease or some diseases, including psychiatric disease, from the symptoms eye view or the thoughts eye view, which I spent so much time thinking about that recently. I think it's such a positive and potentially really fruitful way of doing it. The problem is I don't know what a thought is, and I can't point at one, right? Like even even in terms of introspection, right? I kind of think I know when one begins. Like if I'm kind of trying to work hard and then all of a sudden the thought of like cake comes into mind, I'm pretty sure that's when it arises. I'm not sure I could tell you when it goes away. And I think that's a very simple example, but you can't really define the contours that easily. And so I guess the when we're playing with the idea that something might be an agent, for you, is the answer to whether they are or not, whether that sort of playing that way bears fruit. I mean, is that really the criterion of whether something can be usefully viewed as an agent? Because when it comes to thoughts, there are just an infinite way of combining them together or carving them, and it feels a little bit sometimes like making structures out of clouds, and I guess I'm not sure whether if you made the structure out of clouds and it's solid, is that good enough?
Yeah. Yeah. Okay. All right. There's a few things here of how I think about it. First of all, the kind of metaphysics of it is just I think, as you said, that it has to be whatever it is, it has to be useful. Now, whatever definition we're going to put on it, it has to do useful work. Now, two caveats to that. One is I don't like the binary framing of is it or isn't it an agent. I think there's a spectrum, and what we're really talking about is where on that spectrum is the right bag of tools to use, and how do we know? Well, it either allows a more fruitful empirical interaction or it doesn't, right? So I think we've got that one, that it has to be useful. Now, more broadly though, as far as thinking about what a thought is and things like that, have we talked about my kind of silly story of the creatures from the deep earth? Have we talked about this at all?
I have heard you speak about it, Mike. The sort of the gas creatures. Is that right?
Yeah. Basically, the idea is that the distinction between a pattern in some medium and a physical agent is really in the eye of the beholder. In other words, it is not an absolute thing. We are patterns too, right? We are, to whatever extent we are agents, we are temporary patterns of metabolism and some other stuff. And so I don't think there's a fundamental distinction, but again, there's a spectrum, and there are sort of very temporary patterns that we don't even bother to name, and then there are more persistent things. There's some hurricanes and some solitons and some, and then you get into patterns that are self-reinforcing and have problem-solving competencies, and how they kind of look out for themselves to propagate their own persistence, and so some of these now become more like the kinds of things we associate with agents. So what I see is, as the agent, is I'm now more and more looking at it from the back end of the pattern. In other words, the agent is the pattern, right? And so in any cognitive system, being that either our brain or a computer, some kind of an artificial cognitive system, there are going to be patterns in that medium that have some degree of ability to hang together, self-organize, persist, do niche construction on their environment to make sure they persist. They will interact with others either competitively or cooperatively, and so on. And I also, if you put this together with some of the Platonic space kinds of ideas, your question about which I think is really good. Your question about when does it come into being and when does it disappear? Some of these things, I'm not sure that they come into being and disappear. What I think might happen is at any given moment, they have an interface through which to come through, or they don't. It's sort of like, for very simple ones, let's say very simple ones are forms related to the laws of geometry about triangles, right? So it isn't that they come and go. It's that you sometimes build an interface through which or evolution builds an interface through which they show up, and then you destroy the interface, and they sort of, they're not, but they're ready to come right back when the interface is there. So I think those are the tools that we need to start thinking about this, right? We need to think about these things as perhaps persistent patterns that can come into focus, so to speak, right, and be noticed by other observers such as us, but also other observers such as each other. And these are more persistent patterns. What we're talking about here.
Okay.
Oh, go ahead. Sorry.
So I was just going to ask so say, for example, we're talking about an intrusive thought, and we're trying to take the view of an intrusive thought, and it's something about contamination, say. Are we, in this view, and I understand you've got the sort of the Platonic space, the kind of the patterns which then, ingress, each instantiation of an intrusive thought about contamination or dirt, I guess we're saying then that's not there's a type and a token, I guess, right? So,
exactly.
So that's not the agent, right? The agent is something which is sort of the prototype, because of course there's an intrusive thought about how dirty my computer screen is, but there's also one about how dirty the toilet is, and there's also one about how dirty people are, and again, we can usefully conceive of those as three kinds of agent, but also as one kind, which is just contamination focus, and it's our choice which view we take, right?
Well, yes, and I think there's an idea from kind of these ancient philosophies that is kind of similar to what I'm thinking about, which has to do with individuation, what they call group souls and individuation, right? The idea is that that maybe if you're a colony of ants or something, that there's really one sort of thing that is projected through all these different individuals, and that sometimes on very long time scales, you might have pieces of this thing might sort of butt off on their own and kind of become their own thing. So yes, I think much like with the forms of triangles and such, it is an underlying thing that then projects in different ways onto the physical world about the screen and the toilet and everything else. However, I think it's also potentially, at least for some of these kinds of things, it is possible for some of them to butt off and become their own thing. So maybe you tell me if this is possible, but in the cognitive arena, but maybe it started out as all of these things started out as being the same, just manifestations of contamination. But maybe it starts to take on a life of its own. In other words, right, the thing about the screen, it really just becomes its own separate thing and goes off and does different things. So I think there is this sort of deep structure, but it's malleable, and some of these can, thoughts can have thoughts of their own to some extent eventually, right? They can sort of scale up to butt off and become their own thing. That's how I'm thinking about it right now.
I was thinking that, if we look at the three of us, and look at that as a collection, as a system, then we have a cognitive glue of English language, And if I may offer for the point with exactly the things, Thomas, you mentioned, and you, Michael, that if we offer another cognitive glue of mathematics, then I think, let's imagine, I'm happy to switch because we have a neuropsychiatrist, a biologist, and a psychologist. If we stay with that for just a moment, let's say our goal as a collective agent to look for patterns that are scalable, and then perhaps at some point we'll look for therapeutics, then how about that? If we try to stay that's very basic thing. There are three states: depressed, euthymic, neutral, and manic. If the manifold contains all three, we will agree, in the eyes of the beholder, to call it bipolar. If the manifold contains only two, depressed and euthymic, we will agree to call it major depression. And if the manifold contains only neutral, we'll agree to call it absence of a mood disorder. Basic agreement. There is no universal law of what's pathology and what's disease. Then what I'm trying to say is that if we look for scalability, then this level of dynamics of states is less likely to scale down than just the states. It is a good first step to say, what will depression look like in an anthrobot? The state of depression, right? The state of obsession, delusion, hallucination, distractibility. And if we try to go with that, then I think that with, Thomas, your wonderful document, we have maybe 6 possible experiments to do that. And I'm inspired, Michael, by your work with cancer, where there was a key insight, there was a key epistemic treasure of saying, the cancer stops talking to the neighbors. That was the key thing from which you've built the therapeutics. If we're looking for something like that at the level of, for psychiatry, for example, if we can replicate the state of obsession in an anthrobot or in a planarium, and as opposed to just looking at neuromodulator, which has been done in FEP, they have an entire table of different precisions mapped to different modulators, say, what would that look like bioelectrically? Then we gain this key insight, and from that, we could possibly build something. How does that sound to you? If we try to, I know in building a theory in mathematics, we have to do the axioms, we have to start somewhere. But if we do with what, because I'm thinking if we go with things like schizophrenia or let's say dementia, it's harder because schizophrenia is progressive. We have to say that we have to build the dynamics that it deteriorates. But if we just say a state of hallucination, then that seems to be doable. What do you think?
Yeah, sounds great.
Yeah, absolutely. I think that's the right approach. I think there are so many specific things for the disorders that we work with that are going to be peculiar, not just to humans, but to humans at a particular time or place, or depending on what the most recent edition of the DSM has described, right? So 100%. But even if you scale it to the sort of the dynamics of a system, it's still, so we're still, so you're talking about, say, a system that has 3 different mood states, and what you say, we will agree to call it bipolar. So what's it? There, I guess, is the question, because I understand that it could be a human, but also it could be a planaria or even the cells that exist at the edge of a wound site or something like that. But can that sort of also accommodate a view where, again, I'm just coming, I won't get stuck on this, but thinking of say the thought itself or the mood state itself, right? Because that applies, it's almost, there's something atomic about that. And I'm not sure how or whether we even need to worry, whether we need, if maybe we just don't worry about that because it becomes a bit metaphysical.
I thought, Thomas, that if we're trying to get to therapeutics, then I'm a little worried about the problem of Babylons and just different disciplines and different languages that, to me, to answer your question, what is it? It's just mathematical concept. It's just abstraction. It's just, we describe the manifold. And every living system, according to Friston and colleagues, has a solenoidal flow. We oscillate. We all have cycles. And that's a description of life. Without the solenoidal flow, there's no human being, there's no life. And then bipolar has itinerancy. Bipolar circulates among the 3 states. And that's the definition that we can use as imperfect, but a model of a condition. But in order to get there, if we want to look for scales, I would again say that what would mania look like in an anthrobot and a planarium? which we can proceed with down to the experiment. That makes me very excited if we can discuss that. And then from there, we can say, well, if we've done that, then we can combine from this model of mania in this model of depression, this model, how will collection of them look like? And then this collection evolves in time, which is when we get to progressive conditions like dementia and schizophrenia.
Yeah, I think too. There are two big things that we're tackling here. So I think the thing, Thomas, I think what you're getting at is this business of looking at it from the perspective of the patterns. And I think what Alexey is saying is the kind of broader mapping of these ideas down onto cells and whatever. Those don't have to be done at once, right? So I think that's the thing to remember is that, I mean, in the end, if we want a comprehensive theory, we will put them together. But I don't think we need to fight both of these battles simultaneously. So I think we can focus on one at a time, and then hopefully try to pull it all together.
Great. Yeah, and I agree with Alexei that the trying to look for evidence of these sort of dynamics in simpler systems is probably the most exciting way to start. Yeah.
Well, if you'd like, I mean, I'm very curious to see what you both look like. I actually ran this by Thomas Parr and Daniel Friedman, and Daniel is a specialist in ants, and he was excited, and he talked about these things happening in an ant colony. So if we, in FEP, we have different kind of, every probability distribution has precision, which is inverse variance. So if we have 4 cells, A, B, C, and D, right? And my first sensory thing is that what am I confident that I'm going to see an apple in cell A? This is, if you wish, the first order sensory precision. But the important next step is knowing that there's an apple in cell A, what will happen there next? Sort of the transition thing, right? And if we have an experiment where an agent is in the middle and the 4 cells A, B, C, and D, and B, C, and D don't change very much. I know what's out there and I went there again and it's the same thing. But A is not very predictable. I'm very uncertain, having seen an apple, what's going to happen there next. Certain kinds of agents, those that are capable of inferring about their actions and planning, what they will do under FEP is palpate A more often because there's higher information gain. Let's say pragmatic value is the same, food is everywhere, but I'm not sure what kind, whether it's fat or sugar or, something else. That's, to me, looks like it's being stuck. It's sort of like obsessing about the cell A. And then we can see if that happens with, say, a planarium. I'm not sure it will happen in bacterium because I don't think it can have this modeling of transitions, but planarium could, or a C. elegans, or an anthrobot. So then in the experiment, we have content of the same pragmatic value. Let's say everything is food or everything is neutral in all 4 cells, but one of them is changing fast. If we indeed see that slime mold or is reaching out to that state more often, then we have essentially replicated an obsession. Then we can see what it looks like bioelectrically, right? And that's the first experiment. I mean, but I don't know what it sounds to you like.
So what we could do, okay, so this is what I'm imagining. Imagine, and I don't know if I have it right at hand, but somewhere I have nice videos of this happening. So cells in culture at their outer surface, they're constantly probing the environment. They're making these pseudopodia that are like reaching out and touching things. So what we could do is we could have some kind of an optogenetic thing that with a light stimulation, there are 4 areas, and one of those areas changes, right? So we stimulate it in different ways. The other areas are pretty constant, and we can watch how much time the cell spends exploring the one versus the others, right? So we could do that. That would be that's in physical space, in 3-dimensional space, what the cell is doing. I think I need to think harder, but there also should be versions of this in physiological space. So, right, so that it's not that it's moving in 3D space, it's more like how much time does it spend exploring different physiological states that are right. So we need to map out the space. Maybe it's pH and voltage and a couple of other things, and that's the space within which it tries to and here I suspect that here is buried a huge amount of disease physiology. in terms of all kinds of weird things that happen to people with, where I have a feeling that a lot of this is describable as these kind of disorders, but in other spaces, in physiological, metabolic space and so on.
It's such a great thought. I'll say one thing and then I'll shut up. But with the paper that they wrote with Thomas Parr about the actual obsessive compulsive disorder modeling under FEP, it's not just that I see apple in cell A, but there could be also transition from my action of reaching out here and then doing something next. How confident am I that my action of reaching out for the cup will result in a certain outcome? That's a transition. And if I'm very uncertain about that, if I'm standing outside my door and I want to open it and check the stove in a OCD checking subtype, that is the specific uncertainty that happens in the OCD, which is their big paper. So then, exactly right, we would take the same idea and move it from this very concrete uncertainty about the next state of the cell A to the different state of my action and expectation of consequences. If I'm very unsure about the consequence of my action, that's the issue with transition precision.
I mean, that's also very interesting, because you could imagine, so typically a cell will take a certain action to, let's say, lower its internal pH a little bit.
Right.
And if we interfere with that, such as the cell, well, I did the thing that is supposed to lower the pH, but it didn't. Something different happened. Then your confidence over your ability to control the things that you normally control should go down. And maybe we can simulate, maybe that triggers a bunch of, right. So that's like a disease trigger, is when something happens that makes it harder for cells to believe that their actions are actually having the effect that they think they're going to be, supposed to have. And from there might be all sorts of consequences, as what you just mentioned.
So that's the sort of perturbative aspect where we're sort of trying to recapitulate some sort of disease dynamics, I guess, right? And I suppose it doesn't matter what we call it, right? Because on someone might hear what you're saying about frustrating the intentions of the system again and again, and someone will say that's learned helplessness, right? That's the dog or the rat who's being consistently exposed to some environmental stimulus which it really doesn't like, and it realizes it can do nothing about it, and after a while it will, well, I suppose there's a prediction, right? Someone might hear that and say, well, look, we know what happens to mammals in this situation. Eventually they just give up. They give up and they become, stuporous or lethargic and this kind of amotivational, depressed state. Or presumably there are other stories where you get a kind of extinction burst of trying to change the outcome, and then eventually there's a transition, right? But is the idea, Alexey, that you think that when this perturbation happens, it will then lead to a kind of an enduring shift in the behavior of the system that we're looking at?
Perhaps, but let me illustrate with a second example, and this is where it hits home, where we can possibly gain that insight. Let's say find a bioelectrical profile. Let's take the first experiment, but I hear what you're saying, that we see a behavior and we can label it learned helplessness or obsession. I'm exactly with you. That labeling is a different story. But let's imagine now the 4 cells are equal in all aspects. Pragmatic value is the same, exact food everywhere, and the stability of the system is the same. Let's manipulate the agent with dopamine. And this is what was done not just in silico, but also with ants. With a mild increase in dopamine, they will be foraging more often. They will be more curious, right? Especially ants, for example. Now, if we go up and we increase dopamine even further, I don't know, maybe, L-dopa or something else, then the agent supposedly could become delusional, meaning it may look to us that it is sampling A, but the A is not changing, and the pragmatic value is the same. And I may call it a delusion. I have a precise belief that there's something out there in A and there's nothing there. To me, that looks very similar, and I may be wrong. Now, just in the spirit of labeling it a different way, let's do another manipulation and leave the agent alone without dopamine, and I'm going to drop the acetylcholine by antagonist of acetylcholine. In that specific way, the sensory precision of cell A drops. I'm very, again, kind of, you could see me sampling the cell A, behavior is the same, but we may label it with a different way of hallucination. In one case, it would be very low sensory precision. In another case, it would be very high belief precision. But you may see the same behavior. Because in FEP, it's a balancing act. You have multiple precisions that come together in an equation, and you see sort of how we label it hallucination and delusion. But once we got the experiments, it's no longer a discussion of labels, because then we can actually see what's going on there. And then we can manipulate with, let's say, the dopamine or acetylcholine.
Can I ask a question about the maybe this might be a side topic, but this learned helplessness thing, right? It seems what I want to know is, when does it become pathological? Because it seems like every new being coming into the world has to figure out which things are under its control and which aren't. And so to some extent, finding out that gravity is just there and there's nothing you can do to mitigate it, is that a kind of learned helplessness? Like, when does it become a problem versus appropriate learning about your environment?
So again, yeah, I'm not super sure on the details of the sort of paradigm when it was first developed. I think it was in the 70s, right? But it's an aversive stimulus. I think it's an electric shock or something
Oh,
that's why there's been such a kind of
I see.
some questioning about it. It's an aversive stimulus, which initially the animal does absolutely anything it can do to get away, and then there comes a point where it just gives up, I think.
Because to some extent, and again, I'm just trying to fuzz the boundaries on all of these things. It seems like to some extent that's every living system's experience to some extent, right? So you're a cell, and even though nobody's shocking you, the fact is there's a constant, like, your proteins are constantly being degraded over time. Your metabolism is ticking down. Right, there are things happening all the time, and you just nothing you do prevents it. You can do other things, but there are specific things happening to you all the time that are fundamentally unresolvable. And it's just interesting to me how much of this, I mean, obviously there are extreme examples of, as you say, with electric shock and so on, but it almost feels like a fundamental aspect of being an agent, that there are just some things that are constantly happening to you that you have no control over.
There's a possibility to maybe add a little detail here. Let's go back to a dog that is fighting back out of the cage and trying to get out. The prediction here is that things will get better if I fight. The dog is hopeful. The dog's foraging seeking system is not shut down. It's not depressed. And that prediction, I will get out if I fight, it drives the behavior. Now, learned helplessness means that prediction update changed. I predict nothing good. I am depressed deeply. Then why fight? So that's the change in the agent.
So could this be okay? So could this be where limitations on longevity and regenerative capacity come from? You're a cell, and at first you are hopeful that I can do some things to avoid the entropy and the disorder and whatever, and then eventually you find out that nothing I've done is resolving this. And so to some extent, I mean, it's not complete lethargy, but to some extent, you've given up some of the things you were trying to do in development. You've basically decided that it's just not going to happen. And is it possible that are there any therapeutics that are known to reverse that state? Is there anything we can try? And so now I'm thinking of it as a regenerative, something to put in the biodome to say that, yeah, these cells have basically given up. They've decided that it's never going to work. But can we reset that? Is there some way to reset that?
Yes. Go ahead, Tom. Sorry.
I mean, I guess in some way you can view psychiatric disorders or some even disorders as they're all in a sense a reduction in the possibility space, right? So I mean, even the ones that involve a lot of energy, there's still a reduction in the kinds of activities or the breadth of activities or behaviors that are being sort of engaged in, right? So if you're, or you view it like there's a particularly strong attractor, right? So what that's really saying is there's a reduction in the space of possibility, and then I suppose what we try and do in therapy, and even what we do when we're giving someone an antidepressant, one hopes, is we're not just kicking them into a state of happiness. what I think and what I think the phenomenology of giving people, antidepressants speaks to some extent is a kind of uh, empowerment, or at least assisting the patient to realize what the behavioral possibilities are. That the possibility space is larger than it was. I mean, I guess there's analogies with the cognitive light cone here, right? So it's not that you're kicking them into activity, but the realization is that these things are possible, and so that's why you have that injunction to sort of fake it until you make it. Because even on antidepressants, some people expect I'm going to feel great immediately, and I think that's very rarely the case. But I think what some people do is, finally they realize maybe they can go to the park with their friends, etc. And after a while, that just the repertoire of possibility kind of increases. And I guess for me, I guess that's partly what recovery is expanding that breadth. But I think there's another aspect, which is the ability to actually represent the counterfactual possibilities as well, right? Because there are some disorders, and I guess probably Alexey could tell me maybe the dissociative disorders, but sort of severe depression and perhaps as well, where the people are so unwell that they can't even imagine, they can't even represent what it might be like to be well, and sometimes they can't even remember what it was to be well in the past, and that's super interesting because it's a kind of aphantasia almost of the somatic memory, or the something like that. And so, yeah, I guess in answer to your question, I guess in a way, a lot of, at least maybe the monoaminergic pharmaceutical interventions that we have seem to be those which, rather than specifying an individual kind of behavior, hey, you're going to go and do that, what they do is they open up the space of possibility.
To add what Thomas described, if we get back to three states, euthymic, there's some hope, okay? There's some future, and I'm motivated to do some things, maybe mild enthusiasm. In a depressed state, that collapses, just like Thomas said, counterfactual possibility collapses, and it's hopeless. But, and we can get into a depressed state 7 different ways. You can do an electrode to substantia nigra. You can do, chemically. You can do through sleep, through trauma. You can arrive at that state multiple ways. And then there's no future. And we know that hopelessness correlates with suicidality most strongly. When, people really are like, I should, not do it because there's no future anymore. But in mania, there's a lot of hope. Everything's great. I'm wonderful. And there's too much hope, and it's a little delusional hope, like I can fly, and then I fly and I die, right? So that we know that these things happen, and the installation of hope is therapeutic. It's a long process. Sometimes, it's not as sort of SSRIs or other things, but that's one of the goals in therapy, that there's some hope.
Okay, yeah, very interesting. So 2 questions. First of all, about what you just said, suicidality after hopelessness. Why anything? In other words, if there's no hope for the good stuff to happen, why is the baseline not 0? Why is it to go past that and actually, right, and actually end life? Why not just, well, nothing's happening, so just stay there?
But it's not a neutral 0. It's a painful 0. There's mental pain. And that suicide is the aggressive act, which is homicidal. I want to murder, but I also want to murder myself. So I want to stop the pain. That's the wish. There's the seeking system is collapsing into avoiding pain, but because there's no hope that you can improve it any other way, then it collapses the counterfactual space. So that's the only solution. So.
Is it necessarily that this is what I'm interested in, the hopelessness is necessarily associated with the pain? Is it possible to have hopelessness that is somehow affectively neutral, or does that not happen?
Depression feels bad. Perhaps there can be hopelessness, let's say, in the country without major depression. Yes, we can sort of say, I'm not hoping that particular thing would get better. It's not global. But in suicidality, everything, the entire future, all the possibilities collapse, other than, oh, I have one prediction that pain is going to continue. But everything else is just nothing else will get better.
Yeah, I'm interested in the fundamental relationship, because you can imagine, let's say engineering, even if biology doesn't do this, but engineering some kind of a system that does not believe anything good or interesting is going to happen, but also is just sort of neutral about it. It's not a negative. I want to know, what do we have as living things that make that negative and painful instead of absolutely neutral, right? Clear, that's really interesting, right? The fact that the expectation of something good happening is required to keep you away from a very negative affect. Like, what is that?
I mean, there's a distinction that we often talk about to trainees, which is the distinction between sort of depression and apathy, right? And particularly in neuropsychiatry, in my area, there's this thing of, dad's got dementia, or he's got Parkinson's in particular. As these dopamine affecting disorders are super important for apathy, right? And dad's not doing anything. He's just sitting on the sofa all day, not moving. Is he depressed? Well, how do you feel, Dad? Yeah, I feel fine. No, I can't complain, kind of thing. And he's not depressed, right? But he's not doing anything at all. He's barely taking care of his own sort of well-being. And you don't see sort of suicidal, behaviors in people like that. There's this sort of, I mean, we had someone come and speak about apathy, and he was saying, you look at the descriptions of apathy and you look at the descriptions of sort of nirvana in Buddhism, and they're not that far away from each other. Everything is satisfactory. The unsatisfactoriness of life is kind of gone, and yet, we spend an awful lot of time trying to treat dad who's apathetic and get him up and about and increase his motivation again. Whereas in the depressive state, there's the anhedonia, there's the lack of ability to feel pleasure. But I think at least in many cases, there is that sort of actively painful aspect, as well, which Alexey was getting at. I guess that what's interesting, what's coming up now, thinking about suicide, and it's a dark topic, obviously, but as far as I know, not many sort of higher creatures are known to commit suicide, but apoptosis and sort of self-termination is really quite a common thing in sort of cellular systems. So there's almost this bimodal distribution, and I wonder what that speaks to, really.
Yeah. It's very interesting, and I'm what's in my head now is, why are the cells of the planarian so optimistic, right? I mean, there's almost nothing you can do to a planarian to convince it that it does not have a brilliant future of regeneration. Mammalian tissues give up at the drop of a hat. Amphibians do better than that, but planaria are just, the future is really bright as far as if you're and it's not that you can't die. It's very easy. You can dry out. You can be eaten by a fish. There's a million ways to die. It's not that. You are just as vulnerable as any other living thing, but you never enter the self-limited state where you just hunker down. And I mean, what you just said about the hopelessness and the anhedonia, all that stuff, that's the scar tissue after a limb amputation in mammals. It's just not willing to do anything other than just kind of protect yourself from the outside world. I mean, evolutionarily, it makes sense. If you're running around the forest as a primitive mammal and somebody bites your leg off, probably the immediate survival thing is to scar, inflame, and otherwise you'll never get to survive if you try any of these other things. But nevertheless, it seems like the planaria have a much more, and whatever mania they have about it is well justified most of the time. Like it's right on. It's not crazy. The other creatures might think it's crazy, but you can, I think if you're convinced that, and part of this, I think, the story actually that we've been that we've been developing is that part of why planaria actually do this. And so you guys tell me if this has any kind of bearing in the cognitive sciences, is because their material is so unreliable. Because they reproduce by fission and regeneration, they don't do the sperm and egg thing where our mutations in our body get cleaned every generation. And so that means that you accumulate mutations all the time. So you know your material is unreliable. It's guaranteed you're going to have, I mean, they can be mixoploid. They can have different number of chromosomes in every cell. Okay. So you know the hardware is going to be kind of junky, and it's all up to the physiological software to make a proper planarian, no matter what the hardware looks like. So pretty much. So you've sort of you've developed in a way where you have to be, kind of self-reliant in that way, right? You already know you can't really rely on this stuff, but over time you've developed an algorithm to get past it. So I don't know. I think if there were pharmacological or other tools to reset, I don't know if we're talking about plastogens of some sort or psychedelics or what we're talking about, but if there was some way to reset all those priors and give the tissues, I mean, literally, as we're talking about here, give them more hope for positive future. I predict that's a regenerative therapeutic, actually.
What a brilliant idea. I'm really enjoying our conversation, by the way. Sorry, I'm, smiling. But maybe I'll give you one nuance that I don't know if it would be helpful or not. I want to connect foraging to hope. So, and maybe the answer is scale dependent and not really scale invariant. So before we get to planaria, let's take mammals, for example, right? So then, my goal is to survive and reproduce, even if I have higher, human goals, but as an organism, survive and reproduce. Then, and I'm an agent capable of planning. If the predictive hierarchy is flat, there's no planning. We're talking in a different scenario. Let's say I am capable of planning. What that means, flowing from FEP, is that when all my needs are met, I'm not hungry, I'm not scared, I'm not thirsty, I will forage, I will explore, I will default to seeking in Panksepp terms. Because I need to increase information gain. I need to gain information about the environment. So when something happens, my models are more precise. So foraging is built into the system. Epistemic hunger is built into the system. Now, foraging is hopeful. I'm going to find food because I predict to find food. That's a hope. And if you put me in a state of depression, then I will not forage. And the state of depression in and of itself in mammals can be adaptive, as the theory goes with separation distress hypothesis. Let's say I'm a, baby deer and mom went to look for food or something. I'm in a cave. If I forage, I get eaten by wolves. I must stay put. So my seeking system is turned off. I feel badly. I feel separation distress from mommy. I feel terrible. That's the psychic pain of separation distress, separation anxiety. But my seeking system is turned off because if I stay put in the cave, probabilistically, I will survive longer because mom comes back and I'm okay. Does that?
Mm-hmm, mm-hmm. So I wonder if in the cases that we're talking about with regeneration and whatnot, that foraging is not physical foraging, but maybe exploration of, for example, maybe of metabolic or physiological space. So maybe what's happening is that you're not willing to move around in physiological states, right? And this is why you're staying, yeah, you're staying within a close radius, but in some of these other spaces. Maybe it's in bioelectric space. I mean, that's what we've been working on, is trying to pull these things out of their attractor.
But that idea that you just introduced, Mike, about the sort of, is there a way of rebooting the system and sort of just resetting those priors? I think it was I think you sent the preprint around about the hijacker's guide, and this notion of how smart parasites and hijackers, they get into the system, and the first thing they do once they breach the defenses is they cause a sort of inflammatory shock, which opens a window of plasticity, during which time they then get hold of the controls and they start adjusting the controls to suit them. And when I read that, it was just sort of it was a bit of a light bulb moment, because there's all these interventions that we do, I mean, in medicine generally, but actually in psychiatry, that are basically the kind of control alt delete we electroconvulsive therapy. People talk about psychedelics this way. You can make ketamine, perhaps defibrillation, um, bone marrow transplant, right? They're all a way of kind of resetting. I mean, even some of the old immunotherapies, right? Malaria therapy from 100 years ago. You used to give people this big inflammatory shock, and it would help people with sort of neuropsychiatric illness related to syphilis, right? But it feels like the common thread here is you're pushing the system into this period of plasticity, during which time, if you get the prompts right, you can reorient that system on a really positive trajectory. Of course, if you get the prompts wrong, and I think we saw this, I think in some way, maybe this explains a lot of the post-infectious syndromes. People have this terrible inflammatory insult, and they're unwell, they're stuck, and the body just sort of that becomes a new set point, right? So I think it can go one of both. I don't think the reboot itself is necessarily adaptive, but it's sort of what you do with it.
Yeah, I see. Sorry, what did you just say about the bone marrow transplant? What does that do?
Well, in a way, it's sort of it resets the immune system. I mean, it's a kind of
I see. For the immune. Okay,
broad metaphor, but
okay. I thought there was some sort of psychological therapeutic effect.
I mean, it's being looked at, right? So even in
Really?
neurological autoimmune neurological disorders, there's a role for bone marrow transplant. So things like multiple sclerosis at the moment, it's being used. And of course, as soon as that happens, it's not that long afterwards that you get excitable neuropsychiatrists such as myself wondering, what applicability might this have in psychiatric disorders. But uh, and then you find the odd interesting case report here and there of people who've had these procedures for other reasons, and it turns out that the psychiatric benefits are there.
See, that's extremely
These
interesting because we have examples of very small, basically very small pieces of tissue carrying information that kind of resets the entire host. So when you move, so for example, a tiny piece of a two-headed flatworm implanted into a normal one-headed worm in some percentage of the time will convert the host to being two-headed, even though it's only right. So some of these kinds of memories are very impactful, and they sort of they take over the host, which is always surprising. I mean, like you would think the host would also resist, and it's much bigger, but actually, but this does happen, and so I wonder, in these cases of, as you said, the bone marrow transplant, and for us, if what we need to do as the stimulus, right? So crank up the plasticity, and then the stimulus could be, for example, a temporary presence of some other cells that are more optimistic about the future, so to speak. And that might actually, right, that might actually kind of trigger the surroundings. That really doesn't take much, roughly 3 volt electrically deranged cells trigger metastatic melanoma phenotype in a tadpole. All the melanocytes go crazy, and become this like invasive thing. It only takes a few cells. So there are these weird tipping points that we may be able to take advantage of.
Just wanted to add a possibility, and our, Thomas may like this, it will go very Buddhist. One of the viewpoints, perhaps from Mark Solms, and if you wish, Freud as well, is that the sign of psychological health is lasting contentment, zero, meaning all my needs are met, not actually manic, not too hopeful, but just zero, saying I'm a-okay, thank you very much. And if you take, for example, generalized anxiety, then people are never content. They always persistently worry about this or that or the other. And when we're talking about that reset, it's at least a small window of feeling content. And you have a chronically anxious person, let's say then they have colonoscopy or endoscopy, and the cocktail of drugs administered to them contains an amnestic agent and a twilight anesthesia. They wake up, mind is blank, as if they've been meditating or doing grounding or something. People do that with severe disorder. I'm quoting Bethany Brand and others. in finding common ground, there's a technique there of grounding, which is, if you wish, close to meditation, a progressive muscle relaxation, where you collapse the temporal depth and the person goes smack in the here and now of sensorium and interoception, and suddenly they feel a little bit better, a little more neutral the first time. So this sort of like, if you wish, a healthy therapeutic voluntary dissociation to help them learn it as a skill and then help regulate. But I think these kind of resets is, again, with a long-term goal to have more lasting pieces of contentment. We're human, we will never be perpetually content. We have to feel up, down, and something, that's life. But to have, at least to attain some contentment somewhere and then to increase it is perhaps the goal of a reset eventually.
Yeah. I totally agree. And there's these amazing cases of, so again, I work with this functional neurological disorder where people have these, physical symptoms. They're paralyzed down one side. They have this terrible tremors, or they're functionally blind or something. And there are these rare cases of people who have general anesthesia for something else, and they come out the other side, and the problem's gone, right? And for years in the 1950s and 60s, and I think even a bit before. And I think this is where you get the kind of TV truth serum type stuff from like sort of spy movies and stuff. But there was this procedure, abreaction, where you get someone really, really sort of stoned. You give them, it used to be barbiturates. Now, these days, in the few places that do it, it's kind of benzodiazepines or something. And you get them to a state of, it's such a twilight zone that clinically, apparently, sort of people sometimes occasionally overstep, and the people will pass out. But you get them into this twilight zone of presumably increased suggestibility, or whatever, increased plasticity, perhaps. And rather than just do that and then bring them out the other side, at that point you do the sort of the movement of the limb, saying, look, you can move it, and then that sort of thing, and you prompt the individual. And barring all the ethical concerns about the use of the medications and stuff, which are often super high dose, historically it's reported to be quite effective, right? And so I guess it's that idea of these cells, Mike, who you've got the charisma of the cells, but you've also got the opportunity to make the recipients kind of in that get them a little bit more receptive. And I guess those are the two modalities you can flex.
Yeah. I think there are actionable experiments here for these kind of regenerative therapeutics, around like how much of it is how much of the limitations that we're seeing on healing and rejuvenation, whatever, are due to this kind of these past, these acquired beliefs and the learned helplessness and the kind of these things that could potentially be, and I get it could be ameliorated. And I guess then the next question is how far could you push them beyond normal, right? So as you said, the manic person who thinks they can fly, that's not a great idea. But we've had exceptional athletes and exceptional others who think I can do this crazy stuff, and some of them do it, and right, they do things that normal humans don't do. So who are we to say what's the right? What are the limitations of that?
If I were a planarian, I would be more manic because it matches reality. I mean, you cut me, you do this to me, I survive. So why would I be depressed or neutral? I would be hopeful to survive because that matches reality.
Yeah. And one funny thing was we haven't published this, but I have a video somewhere that you could, so planaria, the way they eat, they have this tube they call the pharynx, which most of the time is hidden, and then it comes out and they sort of vacuum up pieces of food. If you separate that tube from the rest of the worm, they become extremely manic. And because as far as they're concerned, basically what's happening is that the planarian most of the time is suppressing it. It's keeping it silenced. So you get rid of that annoying, body, and the thing goes crazy. And it lives for some amount of time, and it crawls around the dish, and if it finds food, it eats it. Of course, it falls out the other end, which which is pretty funny. So it ends up like burrowing into the food. But these things go wild, and they have this like extremely manic looking activity because they're no longer being kept suppressed by the rest of the worm. Yeah.
I mean,
Okay.
I was going to say, it's just they sound like kids, right? Like, I mean, talking about aging and senescence and kids on the whole don't develop pathologies that are so bad that they become suicidal up until a certain age, and it's shockingly young sometimes. But there is a stage where statistically they're really very safe from those kind of pathologies, and of course that coincides with the period of the most extensive foraging and the kind of manic-like kind of behavior.
Hmm.
So are these planaria just kind of perpetual kids?
Yeah, yeah, very interesting. Just in the last minute, I found it. Let me show you what the what this looks like. All right, ready? So this giant thing here is a piece of liver. Okay. So those are these are the pharynx. It's it's burrowing in. Yeah, they're just they're just going for it.
Ice cream.
Yeah, exactly. I really like that description. The grown up is gone, and I'm going for it. Yeah, that's funny. Okay, cool. Yeah, thanks so much. This has been very interesting. So I think we should put down some specifics um, around what might be the plasticity inducing reagent, and I mean we can think about what some of the actual stimuli would be while when in that state, because that's the other thing is like as you said, right, induce the plasticity and then show it what's possible. Maybe it's literally like you said with the with the hands and everything, a teaching moment. Like you get into the plasticity, and then we actually mimic regeneration in some way to show you like this is what you should be doing. You should be growing, or putting some cells as an example. The cells that are growing. I don't know. There's a million things. I'll think about this, but let's think about what the reagents might be.
Do you mean pharmacologically?
Yeah.
You mean, yeah. So from the kind of the set of tools that we have in psychology.
I think so. I can think of what the stimuli might be, but the plasticity inducers, yeah, that would be cool.
And are you interested in psychedelics in that regard? I think you've
Absolutely,
mentioned it.
absolutely, yeah. Not trivial to get so here certainly, but we can think about it. And then there's a million other things. So we'll obviously have to talk again, because in that outline that we've been working on, there's a million other things that we should talk about.